Hi, so today we're going to be looking at solving exponential and logarithmic equations. So the goal is to solve those, and to do it we're going to use the inverse property. So that's the only goal we have. The problem solving either an exponential or log equations is we can't get the variable out of those using a normal means. For example, if you had like x plus 2, all you got to do is subtract 2. If you had 5 times x, just about the 5. But here, the x is in the exponent. So we can't even use all the strategies we learned with quadratics. What we can use, however, is the fact that those are inverses. And because of that, we can use the skill we learned last time, practice that, which was taking one and writing it in terms of the other. So if you had 180 equals 2 to the x power, there's no direct way to get rid of the 2, but if we rewrite that, we'd wind up with the log base 2 of 180 equals x, and now the x is on its own. And then we know how to do the log base 2 of 180 on the calculator, and we can get value for x. Likewise, if we start with the equation that the log base 7 of x equals 4.3, we can't get at the x right now because it's inside the logarithm. We're doing the log of it. But rewrite it, x equals 7 to the 4.3 power. We can easily do this on the calculator. We know our value of x. 2 to the 3x equals 172. X is up in the variable. There you go. Where we can't get to it right now. So we rewrite that as a logarithm. Log base 2, because remember, it's the same base, of 172 equals 3x. We just use a calculator. Sorry about stuttering there. Log base 2, 172. So we have something around the lines of 7.426 equals 3x. We divide by 3 to get x by itself. Let me erase that and write that over. We're dividing off the 3 to get x by itself. 2.4754. That's what x has to be. One comment I'm going to make really quick about this, though, is at this step here, I wrote that down on my paper to show my work. However, on the calculator, I left the value I got from the log base 2, 172, and divided that by 3. So on the paper, just to keep track of what I'm doing, I went ahead and rounded off. That's why I write everything out. But for my actual computations, I did not introduce any rounding error. I did not round this 7.426 off on the calculator because that will introduce slight problems. I left it alone on the calculator, just divided that number by 3, and then rounded my final answer to 4 decimal places, which is, I believe, is where the book tells you to round. Another example. 7 to the 5x minus 4 power equals 3,000. Again, x is in the exponents. This is an exponential, so we need to write it as a logarithm. Log base 7, because I have the same base as the original, of the number 3,000 equals the exponent 5x minus 4. Use the calculator. Log base 7 of 3,000. And again, I'm going to round it off on my paper, or on the screen here, so that I can keep track of my work. When I do my calculations on my calculator, I'm leaving that full answer in there. Alright, so now it's just a linear function like you've been doing for ages. I'm going to add 4 to both sides. And then I'm going to divide 5. And learn how to write. And I'm going to get 1.62. 229 for my x value. The new part, the part that you need to really practice on, is the part from the last video, which is right there, converting the exponential we started with into the logarithm that allows us to get at our x value. Everything after that point is just plugging stuff into the calculator to get, or stuff from Algebra 1, stuff you know how to do. Okay, so look at the next example. Another exponential, 6 to the 2x power equals 1500. X is in the exponent, can't get to it directly, switch it to logarithm form. Log base 6 of 1500 equals 2x. Use the calculator, and when you get better at this, you can just leave stuff in the calculator. 6 to the 1500. 4.0815 equals 2x. Divide that by 2. Oops. 2. Whoa, what did I just do? X. 2.0408 equals x. Again, there's the new part. That first step. Taking what you have, rewriting it in logarithm form. Everything else is either just use the calculator or Algebra 1 material. So that first step is the one to concentrate on. Alright, this time we're going to go the other way. We're starting with the log of 3x plus 1 equals 5. Notice there is no base there. So what base is that? Base 10. So 3x plus 1 equals 10 to the 5th power. Remember, logarithm is an exponent. Again, this is still the same skill we practiced from last section. This time we're taking a logarithm, writing as an exponential. 3x plus 1 equals 100,000, which is 10 to the 5th. Subtract the 1. This particular problem doesn't even need a calculator. And divide by 3. Again, just to color code this. Here's the thing that's new. From that point down, Algebra 1 level material. You know how to do all the rest of that stuff. That first step, the stuff from yesterday, is the stuff you got to get used to doing. That's what to concentrate on. Log of 7 minus 2x equals 1. Again, it's a common log. Well, 10 to the 1st is just 10, so don't even need to do anything else there. Subtract 7. Divide by negative 2. X equals negative 3/2. This time, same concept, but we have log in a different base. Base 3. We cannot get to x yet. It's inside of the logarithm. So we need to rewrite this as an exponential. X squared divided by 3 equals 3 to the 2nd power, because the log is the exponent. So whatever the log equals, that is our exponent. So that means x squared divided by 3 is 9. Multiply the 3 from the denominator to the other side. So, and then from last chapter, how do you get rid of a square? Square root. But remember, if you square root inside of an equation, you have to take into account both the positive and negative square root. Let's see here. 27 is 9 times 3, so the square root of 9 is 3. And that other 3 is stuck inside the square root. So x is the positive or negative 3 times the square root of 3. Slightly more difficult than last time, but here's the brand new stuff. Just taking a log equation, rewriting as an exponential, or an exponential form rather, and then everything else. It's not algebra 1 level, but it's, well, some of it is. Getting rid of the 3, multiplying to the other side, that's algebra 1 level. That's the stuff we did last section. All right. Little tricky, but not much. Log base 5 of 6 over blah, 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 blah. All right. Switch it to exponential form. Negative exponent means a fraction. You can use your calculator if you need to, but that's 1/25th. And we haven't really done these type of equations that much this year, but you should recognize a proportion when you see it. Cross multiply, 3x times 1 is 3x. 6 times 25 is 150. Divide by 3. X equals 50. So still we have the new step from last section. We're writing the logarithm in exponential form. But if you notice, depending on what is inside that logarithm, a whole host of other skills can be used over here. Here we're using proportions. The last problem, we used some of the information from quadratics. Regardless, they've all had a little bit of algebra 1 level stuff. So it's drawing on a whole host of things that you've already done before. So you just need to kind of remember and think about what you need to do in those specific cases. But this first step, that's the one you really got to concentrate on. That's the new thing. Okay, it looks like I have one more example. Log of 2x cubed equals 4. It's a common log, base 10. So 2x to the third equals 10 to the fourth. So 2x cubed equals 10,000. First thing we have to do is get rid of that 2. So we would divide everything by 2, and that gives us 5,000. Now, how do we get rid of a cube? We haven't really talked too much about cubes. If it was a square, we would square root. Don't know what I just bumped with my finger, but did something. Same idea if it's a cube. We're going to do the cube root. Just like the square root tells us what number you'd have to square to get whatever. Here, this tells us what number we would have to cube to get 5,000. And that is a job for the calculator. 1, 2, 3 for 5,000. And x is about 17.0998. No problem. That's the idea. Use the inverse property. Showed you a bunch of examples going both directions with that. There's the assignment, broken up into chunks. And we'll work on that in class together. All right, thank you.